Hello dear viewers, welcome to today's lesson on the heat transfer. During our last lesson we were looking at the incoming solar radiation balance, where we saw what it is all about, incoming solar radiation, and what it is when we talk about balance, and the different factors responsible for the imbalance that we observe over the Earth's surface. Today we shall be looking at heat transfer. How is heat transferred over the Earth's surface, or between the Earth's surface and the atmosphere? By the end of the lesson, we are expected to be able to define heat and heat transfer. You should be able to explain the different mechanisms of heat transfer. And last but not the least, you should be able to describe the horizontal mechanisms that are involved in heat transfer over the Earth's surface. And further away, we shall look at the vertical transfer of heat, the vertical mechanisms that are responsible for heat transfer over the Earth's surface. Starting with our definition, the first objective of our lesson recommends that we know the meaning of heat. Heat is a transfer of thermal energy between two objects at different temperatures. The transfer of energy between two bodies at different temperatures. While heat transfer is the process by which heat is moved from one object to another. So we are saying that heat is the transfer of thermal energy between bodies at different temperatures, while heat transfer is that process through which heat is moved from one body to another. And heat transfer can occur through conduction, convection, radiation, and latent heat of vaporization. Away from our definitions, let's now talk about heat transfer mechanisms. And in the world, there are two major heat transfer mechanisms. These have to do with the horizontal heat transfer and the vertical heat transfer mechanisms. The horizontal heat transfer here simply talks of the latitudinal distribution of heat over the Earth's surface. That's from the equator to the tropics, from the tropics to the polar regions, and vice versa. Meanwhile, the vertical heat transfer refers to the movement of heat between the atmosphere and the Earth's surface. Talking about the horizontal heat transfer mechanisms, we have the first one here that has to do with advection by air masses and wind. And what is advection? Advection is the transfer of heat by the movement of air or water. The movement of air or water over the Earth's surface tends to transfer heat from one region of the world to the other. Now, for example, warm air masses can transport heat from the equator to the poles. Yes, this is one of the major ways by which heat can be transferred from one latitude to the other, whereby winds that blow over the Earth's surface tend to transport heat from one area of the world to the other. For another example, has to do with water, and we shall come to look at the fact that water transfers heat through ocean currents. Now, ocean currents are large moving masses of water that circulate within the Earth's oceans. They are driven by a combination of factors. In this lesson we shall not go into that, but we shall simply talk of how ocean currents are responsible for the transfer of heat. Now, ocean currents, there are two major types: cold ocean currents, and we have the warm ocean currents. The cold ocean currents are responsible for the transfer of heat from the cold regions of the world, that's the polar regions, towards the equatorial regions, which are hot, while the warm ocean currents are responsible for the transfer of heat from the hot regions of the world, as the tropical regions or the equatorial regions, towards the polar regions. Now, we have an example here whereby warm ocean currents like the Gulf Stream transport heat from the tropics to the northern Atlantic Ocean. So the Gulf Stream is a kind of warm ocean current that takes warm water from the tropical regions towards the northern Atlantic regions. This helps to keep Western Europe relatively mild in the winters. So here we are looking at how ocean currents will help transfer heat from one end of the world to another end. So in line with that, we have this diagram here, this picture that shows the world and the different oceans, and then the different currents that are found within these oceans. Basically, we have two kinds of currents, like we've said before. We have the warm ocean currents, which are represented here in red with red arrows, and then we have the cold ocean currents represented here with the blue arrows. So the warm ocean currents, for example, move from the equatorial regions down towards the poles, as indicated by our arrow here, while the cold ocean currents, I beg your pardon, move from the polar regions, as indicated by this arrow, towards the equatorial regions. So that is what we are saying that ocean currents helped do in order to transfer heat from one end of the world to the other. Now, you see that there are basically two major mechanisms responsible for horizontal heat transfer over the Earth's surface. We talked about advection and ocean currents. Yes, now let's move on to the vertical heat transfer mechanisms. Here we have absorption, which is the first. Absorption, which is a process by which the Earth's surface retains solar radiation. Remember, we said vertical heat transfer is the transfer of heat between the atmosphere and the Earth's surface. Here, if we mention absorption, we are referring to that process whereby the Earth's surface tends to retain solar radiation. When solar radiation leaves the atmosphere onto the Earth's surface, much of it is retained. About 49% of that is retained by the Earth's surface and water bodies. So it is this retention that helps keep the Earth's surface warm, and when the Earth's surface equally emits energy into the atmosphere through ground radiation, this helps to keep the lower atmosphere warm. Secondly, we shall talk about conduction as a major mechanism through which heat is transferred vertically. Conduction is a transfer of heat through direct contact between two objects or between two bodies. For example, when you put a spoon in a hot cup of coffee, the heat from the coffee is transferred to the spoon through conduction. Yes, this is a very good example. Most of us, we take tea in our homes or we eat from ceramic plates. When you dish food into a plate and you carry the plate in your palms, you discover that there is heat that emanates from the plate, and sometimes it is too hot that we are not able to hold the plate. We are forced to put the plate on the table. This heat is sent from the plate to your hands through conduction, or from the food to the plate itself through conduction, because the food is in close contact with the plate. So heat tends to travel from the food through the plate to your hand because there is direct contact between these bodies. Another example here is shown by the pan, the dish, which is on the fire, a pot of boiling water. Now, the fire under the pot heats the pot, and then the pot in turn heats the water in it. It is thanks to conduction. The water is in direct contact with the pot, and the pot is equally in direct contact with the fire. This is why the pot ends up being heated, and the water in it ends up as well being heated because it is in close contact with the pot. Away from that, let's look at convection. Convection is another interesting way by which heat can be transferred vertically. Convection is a transfer of heat through the movement of fluid. Okay, for example, when you heat a pot of water on a stove, the water at the bottom of the pot heats up first. This hot water rises to the top of the pot, where it cools down and sinks back to the bottom. This process creates a convection current that transfers heat throughout the pot of water. This has been illustrated by this cross-sectional view of the pot of water that we had earlier on. As you can see, there is fire under. The pot is placed on fire, and in the pot there is water. The heat from beneath heats the pot. The pot in turn heats the water. Now, if all the water molecules have to be heated, it is thanks to convection, because the warm water molecules, which become lighter, tend to rise towards the surface, and when they reach the surface, they are cooled up again because the surface of the water is cooler than the bottom, which is already heated. And so that continuous rising and sinking of warm air molecules and cold air molecules causes a chain process which is known as convection, whereby water molecules from the bottom rise to the surface and push the cold air water molecules down to the bottom. So that continuous process, rising and falling, is known as convection, and this is what ends up making the entire water in the pot to be hot. Another interesting mechanism responsible for vertical heat transfer is radiation. Of course, the Earth's surface is heated by solar radiation. Remember, during our last class, we mentioned the fact that radiation is the main source of energy onto the Earth's surface. The sun radiates solar energy onto the Earth, and through radiation, energy reaches the Earth's surface. Okay, that's a major way through which the Earth's surface receives solar energy vertically. Now, on the surface, we also have real-life situations that help us to understand how radiation works. When you turn on your stove, when you light up your gas cooker, at times you have to quickly rush away with your hand, because if you do not do, then the heat from the stove can burn your hand. At times too, when you stand close to the stove as it cooks your pot, you feel heat. There is sensible heat that you receive. Another example, when you're back in the village with grandma by the fireside, at times the fire is too warm, too hot, that you find it difficult to go too close to the fireside. You have to shift your chair backward in order to enjoy the warmth from the fire. This is because your fireside radiates heat. It sends out heat. The main source of heat is the fireside, and for the heat to move to the environment, it has to radiate. Okay, so this is depicted by the picture of a burner that we have below. Yes, and this heat radiation travels during radiation as electric electrical or magnetic fields. So the sun generally hits the earth via radiation. Okay, this is one of the major ways by which heat can be transferred vertically over the earth's surface. That said, dear viewers, we have come to the end of the lesson. But before we part, it is worthwhile recalling heat transfer is an important process in the global climate system. Of course, heat transfer is responsible for the global climatic parameters, the global climatic elements, because it is thanks to the transfer of heat that different weather conditions, different weather phenomena are produced. It helps to distribute heat around the world and to maintain a relatively stable temperature. Yes, this is why the poles are not too cold like we would imagine, or like we will expect. The temperate regions as well during winter are not extremely cold, because if they were to be extremely cold, then I don't think life would be able to exist even in the temperate regions during winter. But thanks to the fact that energy is being transferred, especially warm energy, moves from the equatorial regions, from the tropical regions towards the temperate latitudes and polar latitudes, temperatures tend to be moderate or moderated during those winter conditions. The different mechanisms of heat transfer work together to create a complex system that helps to regulate the Earth's climate. Dear listeners, dear students, it is here that we have come to the end of today's lesson on heat transfer. That is lesson 5. And during our next lesson, which will not be far from now, we shall be looking at the global distribution of temperature.